Hello there, this is Miss Nakayama, and we are starting a new chapter today. This lesson is 2.1 Complex Numbers. Again, I know you have done all of this before, so I'm going to try to go over it rather quickly. If you have any questions, please write them down. Please come see me, email me, something of that sort. So what we're going to cover in this lesson is adding and subtracting complex numbers, multiplying complex numbers, dividing them, performing operations with square roots of negative numbers, and then last but not least, solving quadratic equations with complex imaginary solutions. So first off, complex numbers and imaginary numbers. We have something called the imaginary unit I, and it is defined as the square root of -1, such that if you square both sides, I squared equals -1. And in the past, up until this point, or when you're always dealing with real numbers, you have a squared, can't be equal to a negative number, so you would say no solution. But if the directions say solve over the complex numbers, as we are doing in this lesson and lots of this chapter, then you need to remember that I is going to be involved in your answer. So the set of all numbers in the form of a plus bi, where a is the real unit. A and b are both real numbers, but this is called the real part. This is called the imaginary part. Together, they make up the set of complex numbers. Okay, and the standard form of a complex number is a plus bi. So that's how you always will write your answers when you answer problems. The real part comes first, then the imaginary part. Now, to add, subtract, multiply complex numbers, you're going to follow the same methods that you did when you had binomials. And for the most part, that means you're adding, subtracting like terms. And multiplying, we're going to do some examples. So first off, adding, okay? Like terms mean I'm going to add the real parts. The real parts here are 5 and 3. 5 plus 3 is 8. The imaginary parts, -2i plus 3i, together give me plus 1i. We don't write the 1, and so that's 8 plus I. If we look at the next one, 2 plus 6i minus 12 minus I, you've got to remember to distribute the negative over both parts. So if I write that without the parentheses, I'm going to have 2 plus 6i minus 12 and then plus I. That would be the biggest mistake people are going to make. Okay, continuing though, what are our real parts? We're still going to do like terms. So my real parts are 2 and 12. Together that gives us -10 because it was -12. And then my imaginary parts are plus 6i plus I, which is going to give me plus 7i. And that's our answer. And it is in standard form. I'm putting the real part first and then the imaginary part. Okay, next example, multiplying complex numbers. Okay, here you've got to remember the similar thing. This is like multiplying a binomial and a monomial. 7i is a monomial, one term, and a binomial, two terms, and that means I'm going to distribute the 7i to the 2 and to the -9i. So 7i times 2 is going to be 7 times 2 is 14, and then I have an I, so it's just going to be 14i. 7i times -9i is going to be minus 63i squared. And as we just talked about, I squared equals -1. So that -1 has the effect of changing -63 to a positive 63. You have to write that in standard form. So that means my answer is going to be 63 plus 14i. All right, look at this next one. This is two binomials, and two binomials, you want to think about, again, how you did with binomials, and we're going to FOIL. So my first terms multiplied together are going to give me 30. My outside terms are going to give me minus 35i. My inside terms are going to give me 24i. And my last terms are going to give me -28i squared. I squared is equal to -1, so -28i squared is really plus 28. So when I combine my like terms, I've got 30 plus 28, which is 58. And then negative 35i plus 24i is negative 11i. And that's all we got. Okay, now we did add, subtract, multiply, and that's it. Now we got to talk about dividing. Excuse me. In dividing, we use something called the conjugate of a complex number. Sorry, I'm going too far down there. Okay, so if I have a plus bi, then its complex conjugate is a minus bi. They look exactly the same. The first terms are exactly the same, but the second terms have different signs. Okay? And the reason that we do that is I want to remind you of what we talked about a lot. It's from chapter P in the very beginning, but one of the special cases of multiplying was multiplying conjugates, a plus b, a minus b. And what do I get when I multiply them is I get a squared minus b squared, the difference of two squares. Okay? Now, if we apply that to now, our situation now, I'm going to have a plus bi times a minus bi. I'm still going to square the first term and subtract and square the last term. But you got to remember, when you square bi, then I'm going to have a squared minus b squared I squared. And what is I squared is negative 1. So instead of being a squared minus b squared, it's going to be a squared plus b squared. And the key to this, okay, is that now when I multiply complex conjugates, okay, when I multiply, the answer of which is product, then I always get a real number. Okay, so this is what we're going to be using when we divide, because you cannot leave I in the denominator. Okay, but remember this, write it down if you don't know this already. Okay, a plus bi, a minus b, a plus b, a minus b, a squared minus b squared. A plus bi times a minus bi is a squared plus b squared. Very important concept. You use it a lot. Okay, so as I said, we cannot leave I in the denominator, so the goal of complex number division is to obtain a real number in the denominator, okay? And how we're going to do that is multiplying by the conjugate of the denominator. So look at this example, okay? 5 plus 4i divided by 4 minus i. I'm going to multiply by the conjugate of the bottom. The first one stays the same, the second one changes the sign. So 4 plus I, and I got to do the same thing to the top and the bottom. So when I multiply that, it's easiest, I think, to do the bottom. I'm going to square the first number, which is 16, and then it's always plus, and then I'm squaring b. B is the coefficient of I. It does not contain I. It is the coefficient. The coefficient of I in this case is 1, and 1 squared is 1. And then I'm going to FOIL the top. First terms, 5 times 4 is 20. Outside terms, plus 5i. Inside terms, plus 16i. Last terms, plus 4i squared, which becomes minus 4. So when I combine, okay, on the bottom, 16 plus 1 is 17. And then I have 20 and negative 4 give me 16. 5i plus 16i is plus 21i. And as I said, you have to write it in standard form, which means I got to put each one over the denominator. So I'm going to have 16 over 17 plus 21 over 17i. And that's what your answer looks like. Okay? So what we did, we got to remember to put it in that standard form of a plus bi, and we multiplied by the conjugate. All right. Now, another thing you need to be familiar with is the principal square root of a negative number, okay? So whenever you see the square root of negative b, you automatically are taking think of it like this. I got to get the right color thing here. Think of that as the square root of negative 1 times b, okay, which is the square root of negative 1 times the square root of b. Well, what's the square root of negative 1? That's I. So it'll always simplify when you have a negative underneath. Simplify it first by bringing the negative out, and then just treat it like you've always done radicals in the past. Okay? So look at this problem. And I'm going to tell y'all how to do this. A lot of you have calculators that do it for you. If your calculator does not do it for you, ClassCalc will, so I would encourage you to download it and use it. It will be your friend. Okay, so what we're doing here, we've got the square root of negative 27 plus the square root of negative 48. So the first thing I'm going to do is take care of the negative under that radical. I can't take an even square root of even root of a negative number. So I'm going to have I square roots of 27 plus I square roots of 48. Then I'm dealing with the 27, okay, which is 9 times 3. And I circle the 9 because 9 is a perfect square. The square root of 9 is 3. So that means the 9 comes out, but the 3 is left in there, which leaves me 3i square roots of 3. And 48 is 16 times 3. The square root of 16 is 4. So it comes outside of the radical, leaving me with plus 4i square roots of 3. Okay? And we've talked about this a little bit before. This has to be exactly the same for you to add them together. So think of it as a blob. I got 3i blobs plus 4i blobs, and 3 blobs plus 4 blobs is 7i square roots of 3. Okay? Look at this. I got negative 2 minus the square root of negative 3, quantity squared. Y'all, it's that same thing we've been dealing with since the first chapter. Okay? A minus b quantity squared is a squared minus 2ab plus b squared. Okay? So the first thing I'm going to do is simplify that negative, this negative right here, out from under the radical. So that makes it negative 2 minus I square roots of 3. And then I'm going to go apply this because I think it's easier than doing FOIL. So what it means is I'm going to square the first term minus, because this always takes this sign, 2 times the product of the terms, and then square the last one. So in here, I'm going to have negative 2, I square roots of 3, and I square roots of 3. Negative 2 quantity squared is 4. Okay, this right here, I got 2 negatives, so I'm going to have a plus. 2 times 2 is 4. Nothing simplifies with that, so I'm going to have plus 4i square roots of 3. And then over here, I have the square root of 3 squared is 3. And so it's going to be plus 3i squared. I squared is negative 1. So this becomes really negative 3. So when I simplify it, I have 4 plus negative 3, or 4 minus 3, which is 1. 4 by 1, go, there it is. And then plus 4i square roots of 3. All right. The last thing we got to talk about is our square root, our quadratic equations with complex solutions. So you've seen this before, ax squared plus bx plus c. And using that quadratic formula, if you don't know the song, look it up. It's a great way to help you remember. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, this part underneath is kind of important. Okay? B squared minus 4ac, it is called the discriminant. Okay? And if it is negative, then we know that that quadratic equation has no real solutions, and it will have 2 complex conjugates roots that are basically what we just dealt with when we were doing division. So look at this. Last example. Okay? Solve the quadratic formula. Okay? So our quadratic equation is ax squared plus bx plus c equals 0. So that should tell you that a is 1, b is negative 2, and c is 2. So in my quadratic formula that we just had on the page before, anywhere I have a variable, I'm going to put parentheses. Okay? B is negative 2, b is negative 2, a is 1, and c is 2. A is 1. So I'm just filling them in. Now, I will tell y'all what I like to see is how you simplify this right here. So I like to see this next step right here so that I know that you know how to simplify and find the discriminant. So in this case, the discriminant, if I do what's under the radical, I'm going to get negative 4. Now, if you want to put it in your calculator just like this, that's fine. But I need to see this to show your work so I know what you're doing and how you're getting the number. Okay, square root of negative 4 is, of course, 2i. So I have 2 plus or minus 2i all over 2. I've got to break that up because I got to write it in standard form. So that means I'm taking each numerator and putting it over the denominator. So I have 2 over 2 plus 2 over 2i, which becomes 1 plus or minus I. That is all to this lesson. Okay, write down those key concepts that you need to master this lesson. And please let me know if you have any questions. Thank you so much for watching, and y'all have a great day.